Hello everybody, and welcome to Descriptive Statistics Continued. Remember, descriptive statistics are what we do when we are describing and simplifying data so that it makes sense to an audience. We are basically just trying to use the information to figure out something about the data, like what is the average of the class for the exam, what does the distribution of scores look like with the frequency distributions that we did last time. I'm not going to cover central tendency because I think we can do that in class. It's just mean, median, and mode. But I do need to tell you standard deviation, because it's a little bit more complicated with variability in general. You need to be able to calculate the mean, and all you need to do to calculate the mean is add up your values and divide by the number of values. So if you have 4 scores, for example, right here, 8, 1, 3, and 0. To get the mean, you simply sum those up. That's called the sum of x. You add all those scores, and you get 12. And then you divide by the number of scores, which is 4. And then you end up with your mean, or M, as it's denoted in APA style. So M here equals 3. Hopefully that you can follow that part. Because we're going to move on to some slightly more sophisticated, not very difficult math, but still, it can be confusing. Alright, so the idea behind standard deviation is basically, it is an average difference. If you can just keep that in your mind, it is kind of a mean of its own. It's an average deviation of each score from the mean of the distribution. So if the mean score on an exam is 75, if you get an 85, then your deviation score is 10 points above. So we're going to calculate what the average difference is. So your score might be 10 points above, someone else's might be 3 points below. We're going to average those out and basically add those up and figure out what the average difference is. How far away, how many points away is each score from the mean. Hopefully that is going to be the conceptual idea that you come away with here, and I'm going to show you using the not the calculating formula, but the conceptual formula. And here, as you can see, there are 2 kinds. There's the sample and the population. And the sample and the population are always going to differ slightly. The population is the entire group to which we want to generalize our findings. The sample is the subgroup of people that we actually realistically can get to do our study and give us the data. So there's always going to be a little bit of a difference in there, and that difference is usually called the standard error. How much different is our sample statistics from our population parameters, if we can even know what those are. So I'm going to show you how to calculate it with the sample, but because we almost never have the population data. But just note that this is called sigma, and mu is the denotation for the mean at the population level. Just think population, kind of difficult to get, kind of not very typical for us to do, and so it's all Greek to me idea, and so therefore when you see these Greek letters, then you know you are in population land. When you see regular old letters that make sense to you, except for the summation sign, but you're going to see that a lot. Once you see those regular letters, you know you're in sample land. So this looks kind of like a scary formula, but really all it is it's an average. But we have to do a couple things to make the average work. What I was trying to show here, and I don't know if you can see it, but basically if you take the mean difference,